All right, so I think we left off right in the middle of this problem, so we'll continue from there. Okay, sorry. So 5 pi over 3 we decided is outside of our restricted domain for cosine, so we can't use the cancellation property. So we're looking for cosine of 5 pi over 3. So 5 pi over 3 is here, and cosine is positive 1/2. So positive 1/2. So cosine inverse. So what angle gives us a cosine of 1/2 but inside our cosine domain? So in the cosine region, it's the x coordinate. So we get this angle right here, which is pi over 3. Right now we're moving on to tangent. So remember that our tangent restriction goes between negative pi over 2 and positive pi over 2. So it has the same region of angles as sine did. So I indicated that with my squiggly blue region. So over here, if I want to know tangent inverse of 1, that means what angle gives me a tangent equal to 1. So tangent is equal to 1 here at pi over 4, because something divided by itself is 1. And it's also equal to 1 over here, negative square root of 2 over 2 over itself equals 1. This one is the one inside my domain of tangent, so it's going to be pi over 4. Now I'm looking for inverse tangent of the square root of 3. So what angle in my appropriate domain gives me a tangent of the square root of 3? I worked some of these out here. So this angle has a square root of 3 in it, so it's a candidate. So tangent would be sine, which is 1/2, divided by square root of 3 over 2. So times 2 over the square root of 3. 1 over the square root of 3, rationalize the denominator, I get square root of 3 over 3. So that's not it. It's not equal to square root of 3. So let's look over here. So this would be sine over cosine, and it's just the reciprocal of this stuff. So this one's going to work out to be square root of 3, but negative because one of each. So I was looking for where is the tangent equal to positive square root of 3? Sorry, my puppy's making silly noises. And if you look up here, again, reciprocals of the one I tried before. So the tangent here is equal to the square root of 3. So pi over 3 is my answer to this one. All right, this one's a calculator problem. So pull out your calculator, and you want to literally just type this in. So if you're looking for your inverse tangent button, it's a button, but it's the shift one, so it's above the tangent button. So you would type in second, and then tangent, and then 15, and you should get 1.504. If you don't, it's because you have to change it to radian mode. So make sure you're in radian mode. We've got just 4 problems left. Let's see if we can zip through them. So tangent inverse of tangent, the cancellation property might work, but I have to check if negative pi over 3 is in my restricted domain for tangent, which is here. So negative pi over 3 is right there, and it is inside my appropriate domain. So I can just cancel inverse tangent and tangent, and I get negative pi over 3. Now let's look at this one. So again, tangent inverse of tangent. So maybe I can cancel, but is 3 pi over 4 in my restricted domain? So 3 pi over 4 is over here, but my restricted domain is over here, so it's not. So I want to first find tangent of 3 pi over 4. So 3 pi over 4 is here. Something over itself is 1, except I've got one of each plus minus, so tangent here is negative 1. So now I'm doing tangent inverse of negative 1. So what angle in my appropriate domain gives me a tangent equal to negative 1? So I'm looking here. So tangent equals negative 1 right there, because I have one of each sign. So that would be negative pi over 4. So negative pi over 4. I'm going to stop it, and we'll have one more video.